of the dipole as well as on the equatorial line of the dipole. Okay. Now see, first electric field at any point on the axis of the dipole. Now suppose as shown in the figure, we take a dipole. Now axis of the dipole, that is the axis passing through both the charges, or that is coinciding with the line joining to these two charges. Now suppose at point X on the axis of the dipole, we want to find the electric field. Now this particular point where we want to find the electric field is at a distance r from the dipole. Always remember this thing, the distance of any point with respect to dipole, that will be considered from the center of the dipole. From the center of the dipole. So from the center of the dipole, the point under consideration, that is at a distance r. Now at x, if you want to find net electric field, then we have to take the electric field due to plus q charge as well as minus q charge. And then after we have to take the vector summation of these two. Okay. Now electric field here due to plus q charge, that will be in outward direction. So that will be in the direction as shown in this figure, as well as due to negative charge, that is towards the charge. So E minus Q, that will be in the direction as shown in the figure. Okay. Now E plus Q, that is equal to, as per equation, KQ upon R square. Now the distance of this point with respect to plus Q charge. So from center the point is at distance R, center to plus Q, that is at a distance A. So plus Q to this point X, that is at a distance R minus A whole square, we can write, and see the direction of E plus Q, that is in the direction of dipole moment. So here multiply this one by P caret, which one is the unit vector in the direction of dipole moment. So this one is now vector form. Then after E minus Q, that is equal to, again as per equation, KQ upon R square. KQ upon, now distance of point X from minus Q, that we can write this R plus A. So here we have to write R plus A square. Now the direction of this electric field, that is in the opposite direction of dipole moment. So here we have to multiply by unit vector but with negative sign, so minus P caret. Now see, here we have to write actually the symbol of vector like this. Okay. Now resultant electric field at point X, that is the vector summation of these two. So resultant electric field vector E, that is E due to plus Q and plus E due to minus Q. So we can write KQ upon R minus A whole square P caret minus KQ upon R plus A whole square into P caret. So now we can take KQ common and write down P caret outside the bracket. So into bracket 1 upon R minus A whole square minus 1 upon R plus A whole square. So simplify this one and then take LCM. Now see, this into this, R minus A into R plus A, that is R square minus A square and square of it. So that is the denominator. Then numerator, R plus A whole square multiplied by 1 and R minus A whole square, that is with minus 1. So resultantly, we will get KQ into bracket R square plus 2AR plus A square minus R square plus 2AR minus A square. So R square and A square cancelled. Resultantly, we will get E that is equal to KQ into 4AR upon R square minus A square whole square into P caret. But now this 4 is divided in two parts, 2 into 2. So we can write K into 2, then Q into 2A into this R P caret as it is, and this one R square minus A square whole square as it is. But Q into 2A, that is the magnitude of dipole moment. So we can write electric field E that is equal to K 2 P R upon R square minus A square whole square into P caret. Now, this one is the equation for electric field at any point on the axis of the dipole. Now, this equation can be used for any point situated at any distance on the axis of the dipole. But suppose here we consider one special case in which we consider if R that is very much greater than A. R that is very much greater than A. Then in that particular case, we can write R square minus A square that is nearly equal to R square. Now, here we can neglect A square. So we can write now E that is equal to K, this 2P. If A square is neglected, then here we will get R square squared, that is R raised to 4. But in numerator 1 R is there. So 1 R from numerator and denominator will be cancelled. So we can write 2P upon R cube here into P caret as it is. So here we can observe this thing, the electric field of electric dipole that proportional to 1 upon R cube. And we discussed electric field of a point charge that proportional to 1 upon R square. Clear to all of you? Then after,